Section 5, or this is the fifth of six. This is the fifth of 6 sections that we have on our test on Friday. Reminder that those of you who are doing yearbook or are going to be out on Friday and not because of sickness, you're going to be taking your test on Thursday. I have these study guides that I can pass out today. I will pass these out to you. These are not due until Friday. Okay, these are not due until Friday, but I'm going to give it to you early because as Maddie requested during first quarter, and so many of you request often, you want it earlier, so I'm going to give that to you. Yes?
Thursday I have to take William George test in an activity, so I'm checking that will be a Friday.
6th period. 6th period. Yes, sir?
Do you have to do the whole study guide?
I don't understand why you wouldn't, but yes, that's also. I will be posting answers on Thursday. Yes. Okay. Is there another question? Yes, sir.
Can we have a study session this time? Because I don't want to bomb
I think I work Wednesday after school, but Thursday. Yes, we will make a name for me. I can. We can have a short one. Because we can have one until 3:45. Thursday. Thursday until 3:45. Because that gives me enough time to get to the high school to do my coaching duties. We are going to choose
Thomas LeBron.
Thomas LeBron? Yeah.
Okay, LeBron Thomas.
Speaking of LeBron, go Bulls.
I like the Bulls. I don't like the Bulls. I want them to
That's
make
it.
the Cavaliers.
You don't have to like the Bulls. That's fine.
Pacers are better. I know. Pacers are better.
The solution to the system is the ordered pair that solves both equations. Or in other words, the intersection. So in other words, the intersection, where they meet, where these two lines meet. And this is resembling the slope-intercept form, y equals mx plus b. And our first thing that we're always going to want to do is make sure that our equation looks like y equals mx plus b. The first one is fine. We don't have to worry about it. Oh, and also, when you guys get up, make sure your desks are just how they are right now. None of you are too big that you can't maneuver out of the desks. If you are, if you don't have that flexibility, then I'll put you on the edge of one of the sides. But I'm 6'3", 200 plus, and I can maneuver through there with not so good knees. I'm doing that to show you that we're doing 2 columns. You don't need to write that line yet. You will, but not yet. So we are going to map out these 2 equations. So let's map them out. We have y equals 2x. And as I look at this, I remember that the slope-intercept form is y equals mx plus b. That was from yesterday's notes, where the m is my slope, the b is my y-intercept. So I'm going to identify what is my slope in this situation. What is the slope there, Trey? 2. Now this b is a little bit tricky because it's supposed to be right here. But if there's nothing there as far as integers go, what is it? 0. 0, yeah. You're thinking of multiplication. We'll use that. That one's next, actually. So we have 0. So I'm going to graph that one in blue. I have my y-intercept point is 0, and my slope is 2. Now, I like to do my slope as a fraction, because if you remember, slope is rise over run, change in y over change in x. So this is how many times it's going to go up. This is how many times it's going to go to the right.
So only when it's negative we go left?
Correct. Actually, I'm going to show you how you can do left with this slope as well. Okay? So I have the intersection point is 0. I'm going to go ahead and zoom in on this so my trusty 4th and 5th period people can see it nice and close. So my slope, as we found, is 2. It's 2 over 1. You don't have to write that. I'm just rewriting it for people to see at home. There's my slope. I'm going to go up 1, 2, and over 1. Up 1, 2, and over 1. Rise 1, 2, run 1. Rise 1, 2. Oh, okay, that's enough. I just kept going with that. I want you guys to have 3 points. Now, do you agree that -2 over -1 is equal to 2? Okay, good. I'm glad you do because it's true. In order to do that, I can still have that be my slope because my slope is 2. What's the opposite of a rise? Yeah. Down. So if I have that still as my slope, I'm going down 1, 2. If I'm not running forward and I'm running backwards, that's going to be back 1. That's how you can do the other way. So then I'm going to take my school-issued straight edge. I'm going to take my school-issued straight edge, and I'm going to go ahead and draw a line. I've got my ID on me because that's how it's supposed to be, and I'm not chewing any gum because that's what people are finding all over the place right now. If you have gum, here's your chance to toss it without getting sign in it. Thank you. So I'm going to graph this line here. Oh, that's bad. Let's try that again. There. All right, let's go. Let's go. Spit it out. Sit down. Then I'm going to do tiger orange for the next one. Y equals -x plus 3. What is my slope with this one? Y equals -x plus 3. Josh? -1. Beautiful. -1, and because I like to have it be rise over run, I'm going to do that. And then I have my B, which is just plus 3.
How come x isn't 0? Why is it a
X isn't 0?
You know how n is equal to -1. Why is it -1?
Because of that. Yep. Because how many Olivias are there?
Well, currently, I can't get that.
Okay. So you rather than saying like one Smith, it's just Smith, that sort of thing, like Mr. Smith, not one Mr. Smith, that sort of thing. All right. So there's the graph of that one. So now I'm going to graph this guy. It intercepts y at 3. My slope is -1, 1. So I'm going to fall 1, run 1. Fall 1, run 1. Fall 1, run 1. Fall 1, run 1. And I just kept going with it because, oops. I just kept going with it because, oh my goodness, what did I just do? Whoa, okay. Yes, sir? I started at 3 because that's the intercept point. And I have those there. I'm going to draw with a purple, or an orange, my line.
We're going to find out what the intersection of both of them is.
Yep. It's really thin, but whatever. Okay. So it's not a perfect line, but I can see where my intersection point is. And it looks like it could be at, what do you think that line of intersection is, people? Let me get out of your way here. There. What do you think that line of intersection is, Mr. Watson?
1 and 2.
1 and 2. So looks like they're going to intersect right here at 1-2. So if that's the case, we need to find out if this is the truth. So I'm going to write solution. 1-2, ? I'm Ron Burgundy. Oh, that's why it didn't fit. Draw. I'm going to use green. Solution 1-2 question mark. Oh, not that B. That was because Olivia asked a question. So in order to do that, if I want to find out if this is a solution, I have to enter those values of x and y into both of the equations to see if it's a solution for our system of operations. So I'm just going to plug in this x and this y into this guy and this guy. So let's do it down here. We have y is 2, x is 1. Then for this one, y is 2, negative x is 1 plus 3. 2 is equal to 2, yes? Cha-ching! Check mark. 2 is equal to 2, yes? Cha-ching! So we're checking to see if that is a system of equations, if they intersect. Yes, sir? Nope, because x, x, x. 1, 2, 3. Whoops, forward. There we go. Let's try another one. We have to make different. We have to make different values. So if you could please add zeros to all those values. Add zeros to all those values because that is not big enough. So we're adding zeros to and then for the next one, let's see, how can we do it? I did not like this example, but that's fine. Let's go by threes. Let's go by threes in this one. So it's going to be 3, 6, 9, 12, 15, 18.
For 1, 2, 3, 4.
Yeah, so ignore. If we all had Chromebooks, we could all have Microsoft OneNote. We could do that. Do you? How you like it? That's what Bethalto uses Chromebooks, I think. And Roxana?
Yeah, they do.
All right, once again, I'm doing this line. I'm doing this line to separate the two sides that we're going to be doing. Now, here's a situation where algebra does this just to make sure that you don't understand too much. So yes, I'm hating on algebra with you. They like to add different kind of variables in there and try to recognize if you see what's going on. Whenever we have y equals mx plus b, there's going to be a standalone. M is the coefficient, x is the variable stuck to that coefficient, and there's going to be a number that's just chilling by itself, because b is chilling by itself. So I want to make these look more like what I'm familiar, which is going to be c equals 0.1n plus 10, because that's going to resemble y equals mx plus b more. A coefficient is a number that's stuck to a variable, to use proper vocab. Then I'm going to rewrite this one as well. C equals 0.2n plus 5. I'm going to choose ugly, gross green. So the first thing I'm going to do is, after I do that, so that's not the first thing. The next thing I'm going to do is, I don't really like decimals when I'm dealing with rise over run, because I can't really see that 0.1 is a slope. I can't see that point 1 is a slope. So what I'm going to do is I'm going to rewrite this so it looks more like a slope. I'm going to rewrite that so it looks more like a slope. Do you agree that 1/10 in decimal form is the same as 1/10 in fraction form? Yeah. And I'm just going to rewrite this one while we're at it. That would be a different color. So now I'm going to identify what is my slope for that one. Schelling, what is it? Well, you're looking at it. It's right here. Which of these is the slope? Is it C equals? Is it the C? Is it the equal sign? Is it the 1/10? Is it the N? Is it the plus 10? You were here yesterday, weren't you? How did you do on the homework? How did you do on the homework? The last couple? By chance? Okay. Okay. Then it makes sense. That's why you didn't recognize that. Okay. Because that's where I'm referring to the last couple of questions. Dara? 1/10. 1/10, because that's what's taking the place of this M that I have highlighted in the upper right corner. M equals slope. Awesome. It's always going to be the one stuck to the variable. It's always going to be the one stuck to the variable. Yep. Yeah, 1/5, yes. Yep. And then we have our y-intercept, which is 10. On this one, we have our M is what, Austin? What's our slope for this equation? I want it to be rise over run. That's the same thing as point 2. And then my point where it crosses the x-axis, or the y-axis is there. So I'm going to graph this now. So now we're combining what we did yesterday, what we combined 2 days ago's class. So it crosses at 5. I'm going to put it right there. The red crosses at 5. And I'm going to go up 5. No, sorry. Rise 1 over 5. Rise 1 over 5. It's going to be gross. Rise 1 over 5. Ugh. See, why is it so big? That's so silly. Yeah, this is just put the intersection point at 50, 15. We're going to go back. We'll go backwards for this one. Okay, we're going to go backwards to this one. Put the intersection point at 50, 15. 5, 0, 1, 5. And draw a line. Then I'm going to graph the other one. Oop. Ooh. This one crosses at 10. Up 1 over 10, blah, 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 blah. That's where it goes. So that's what your 2 lines should look like. Then we're going to plug it in there and see how it goes. So our intersection point that we graphed out and mapped out in this bad example that the book made. Question? I know you guys are asking each other math stuff. I know you're not just chatting. Do you have a question? No? Okay. You're not in trouble. I heard you asking a legitimate question about what we're doing. Too legitimate. All right. So now in order to get that, I need to find out, is 50, 15 a solution? 50, 15, is that a solution?
Yes, it is.
So let's plug those in there. Why is there so much rustling? Leave Russell out of this. Rustle. Like what you do in the leaves? Not you necessarily. X is 50 plus 15. So let's see if that one works. This one is, oops. No. I'm jumping ahead of myself. Plus 5. There we go. And this is, y is 15. So then we have 15 equals 1/10 multiplied by 50 plus 10. 50 divided by 10 is 5 plus 10. 15 is equal to 15. Ching. $50 divided by 5 is 10. That works. We kind of worked backwards on that one, but the bottom line is this. That was... The main reason I wanted to show you this one is because I wanted to show you that you can have big numbers. You can have an intersection that goes way out on the y. Moving along. Solve this, what? That's what I'm hoping for. We're going to pick up the pace. These ones are already in the y equals mx plus b, so I'm going to... Question? Do you have a question?
You won't give me back my eraser. I heard him earlier whenever I was just writing something, and he said, I'm just going to take this. He was thinking I don't have his zebras.
Okay, here's the thing. Is it possible? YouTube, I'm going to mute you because I have to deal with some middle school ridiculousness.
He says that he'll fight when they're done with class.
Have a seat over here just to reduce the tension right now.
Right here.
Right there. Y equals x plus 3, y equals x plus 4. No, I unmuted it. Thank you for double checking. Our slope, I'm going to shoot through this. Our slope is the number that's right there. 1 is equal to 1x, which is equal to 1 over 1, so I can have it be rise over run. I have my y-intercept, which is b, and that's the number that's after the variable plus 3, so it's going to cross at 3. My m for this one is also 1, which is 1 over 1, because I want it to look like rise over run, so I can do this more efficiently and know that I'm getting the correct answer. My y-intercept for the second guy is going to be 4, because that's where the b is. It's after the variable. What am I talking about with the b? Y equals mx plus b. I want it to look like that. So I'm going to have this one be purple. I'm crossing at 4. My intersection, or my rise over run is 1 and 1, so it's rise 1 over 1. rise 1 over 1. I want you guys to do 3 lines, please, or 3 plot points whenever you're finding the line. Yes, sir. We're not done. We're not done. Nah, I just barely missed a huge sneeze. Okay, this one's going to be pretty in pink. This one's at 3. It's up 1 over 1. Up 1 over 1. Up 1 over 1. The other day, we talked about lines that have the same slope. Both of those lines have the same slope. So they are parallel, correct. And a solution is where 2 lines intersect, right?
Yeah.
So what is the solution to this problem?
Intersection. Is it 0?
No solution. There is no solution to that problem because those guys are parallel. Trying to think of an analogy for it. Let's see here. Yeah, I guess we could get that practice in. All right, this one here, I'm going to shoot through this because I want to finish these notes because there's someone who needs these notes in 10 minutes. So, we have y equals negative 2x plus 3. I already have that in y equals mxb plus, y equals mx plus b form. So my slope is negative 2 over 1. My y-intercept is 3. This guy is not being nice. He has something stuck to the y. So I have to get it unstuck from the y. In order to do that, I have to divide both sides by 3. Negative 6 over 3 x plus 9 over 3. I'm showing every step, so when you guys look back at this, you can see what was going on. Negative 3x plus negative 2. Whoa. Negative 2x. Would you erase? Negative 2x plus 3. Now I finally have this. My slope is negative 2 over 1. My b is 3. Good. Yes. It's the same exact problem. It's the same exact problem. Look here. It's going to be the same exact line. It does kind of look 3D. So it's the same line. We know how to draw them, but we need to get through this, so same line. So it's all solutions. Let's see make sure I use the right wording here. Yeah, so it's infinite solutions. So it's infinite solutions. Infinite Solutions Incorporated.
Could you do
All solutions, yeah, infinite is all. Infinite is all. sounds like we're writing a sci-fi picture. The graph is several equations as shown to the right. State the solution. This is very fast, and there's a section like this on your H-dub. There's a section like this of your H-dub. So I'm looking for number 1, I'm looking for A and C. These guys here, it's this point. That is the solution. What is this? So what is the correct answer? Let's see. Who haven't I heard from today? There you go. Negative 3, 3. All right. Negative 3, 3. Those are super simple. All right. There is a section like that on your homework. Let's smith the rest of these. But just because we need to move along. We have like 2 minutes left. I do want to get to one of these. We have 3 minutes. Be quiet. Don't talk about how much little time we have, so I have to stop you from talking about how little much time we have. So we're just going to graph these guys. Let's see here. This is graph the sketch of each of the 2 systems of equations. I skipped down to number 25. So for this guy, my slope is negative 1. My B is 2. So I'm going to do, here's my y-intercept. My slope is negative 1. Get my ID out so I can... All right. Then I have this guy, just saving time. M equals 2 over 1. B equals 5. So here's my 5. I have 2 over 1, which is up 2 over 1. Up 2 over 1. I found my solution. What's my solution? Yes? Negative 1, 3. Negative 1, 3. Checked it. Yeah. And you would do the same for those guys. I mean, it's pretty much the same stuff. I do want you to finish those graphs there for homework, okay? Because when I get your notebook collected on Friday, I'll expect to see those, and they're supposed to be done. When you get out of your desks, do not move the desk except for Dara, because yours is a weird spot. Anyway, I'm going to pass out in the next, I have 60 seconds by YouTube. I'm going to pass back